Welcome to the next episode of the sorting functionality for the inventory. Today, we will create the widget that will allow us to sort both the inventory and the storage box. Let's jump right in. Navigate to the Inventory System, UI, Widgets, Inventory folder in the Content browser. Create a new user widget and name it WB_sort by menu. First, search for a horizontal box. Drag it into the hierarchy. This will serve as the container for our sorting controls. Next, search for a combo box string in the palette and drag it onto the horizontal box. This combo box string is where we will display the sorting options. A key difference between combo box key and combo box string is that combo box key works with predefined keys in data structures, while combo box string displays simple strings that are easier to configure dynamically. After that, search for a spacer and add it to the horizontal box. The spacer creates some distance between elements, improving the layout. Then, search for a button and drag it onto the horizontal box. Finally, look for a text widget and place it inside the button. This text will display the button's label, making it clear what the button does. With this structure in place, we are ready to style and set up the widget. Select the button and rename it to Sort Button to make its purpose clear. To keep the editor more organized, collapse or expand settings as needed. In the Appearance category, expand the Style section. Here, you can adjust various design settings for the button. First, change the normal style color to hex 6x2 and FF. This sets a dark gray color for the button's normal state, giving it a sleek and modern look. Next, expand the hovered section in the button's style settings and set the tint to hex number 4D4D4DFF. This creates a lighter shade of gray when the button is hovered over, giving clear visual feedback. Then, expand the pressed section. Change the tint to hex number 505050FF. This slightly darker gray provides a subtle but noticeable feedback when the button is pressed, enhancing the user experience. Scroll further down and uncheck the Is Focusable checkbox. This ensures that after interacting with the button, the inventory remains responsive to the assigned keys for closing, preventing any unexpected behavior. Next, select the combo box and rename it to Sort by Combo Box for clarity. Scroll to the top until you see the Content category. Here, you can define individual drop-down options for the combo box. This allows you to specify selectable items for the drop-down menu. Additionally, you can use the Selected Option parameter to define which item is pre-selected when the widget is loaded. We will, however, populate these parameters dynamically within the graph to keep the implementation flexible. Therefore, we will not configure them here but instead move to the graph after completing some essential settings. First, adjust the content padding to 6:4. This ensures the drop-down content has appropriate spacing for better visuals. Next, expand the Style category and locate the menu row padding setting. Change it to 4 to make the drop-down rows slightly more compact and visually appealing. Scroll down to the Item Style section. Expand the Active Hovered Brush parameter and set its tint to black. This changes the background color of an item when it is actively hovered over, creating a clear highlight. Collapse this section when done. Next, expand the Active Brush parameter and select a dark gray color. This sets the background color of an actively selected item, ensuring it stands out in the drop-down. Further down, look for text color and change its value to #D1E2F, giving the text a soft, readable light green shade. Then, find selected text color and set it to the same value as text color, ensuring consistency between the displayed text and the selected option. Feel free to explore the other customization options here, such as the scroll bar styling and other parameters. There is an incredible amount of flexibility available, so take some time to experiment and see how you can enhance the drop-down's appearance further. It is worth it. Under the Font category, ensure the font size is set to 16 for clear readability. Next, change the foreground color to #D1E2AF to match the text color we set earlier, keeping the appearance consistent. Scroll down to find the Is Focusable checkbox and uncheck it, just as we did for the button. This ensures that interacting with the combo box does not interfere with the ability to close the inventory using the assigned keys. Now scroll back to the top and locate the Style category. Expand Style and then Combo Button Style. This section provides additional button style settings specifically for the drop-down button of the combo box. These settings are identical to the button settings we configured earlier. To save time and maintain consistency, go to the hierarchy, select the Sort button, and collapse all its settings for clarity. Locate the Style property of the button, which we configured earlier. Hold the Shift key and right-click on the Style field. This will copy the button's style configuration for reuse. Select the Sort by Combo box again, then hover over the button style property in the Combo Button Style section. Hold down the Shift key and left-click on the button style field. This action pastes the style configuration we copied from the Sort button, ensuring that the drop-down button matches the appearance of the main button, keeping the design consistent. With the widget now configured for testing, we open the graph. First, delete the event construct and event tick events, but leave the pre-construct event. From the execution pin of pre-construct, add a for each e_sort items by node. This node loops through all the values of the e_sort items by enumerator, making it easy to dynamically iterate over each sorting option. Next, drag the Sort by Combo box into the graph and call the Add Option node. Connect the loop body of the for each node to the execution pin of Add Option. Then, take the enum value from the for each node and connect it to the option input of the Add Option node. This dynamically populates the drop-down menu with all sorting options from the enumerator, ensuring the setup remains flexible for any future changes. With this complete, the Sort by Combo box is now ready to display all the sorting options from the enumerator. Drag the Sort by Combo box into the graph and call the Set Selected Index node. This allows us to set the default selected option dynamically. Connect the completed execution pin of the for each e_sort items by node to the execution pin of Set Selected Index. This ensures that after all options have been added to the Sort by Combo box, a default option is selected. We add the comment init sort box and set default value by index. When you open the designer, you might notice that the default option in the Sort by Combo box appears empty, even though the selected option is set to name. This happens because pre-construct is setting up the options dynamically at runtime or during preview, but it does not directly update the default option field in the designer. Instead, it updates the selected value programmatically based on the enumerator. We use pre-construct instead of construct because pre-construct is executed both in the editor, when previewing or configuring the widget, and during runtime. This makes it ideal for initializing elements like drop-down menus or setting default values dynamically while also allowing us to preview these changes during design time. This ensures that the widget is both functional in the game and visually accurate in the designer. Go to the graph and add a custom event named Execute Sort Action. Add a new variable called slots container with the type wb_slots container object reference. Drag the slots container variable into the graph, right-click it, and select Convert to Validated Get. This ensures the logic only executes if the variable is valid. Connect the execution pin of the Execute Sort Action event to the isValid node of the validated get. The event will also have one input named Selected Option with the data type string. From the isValid execution pin, add a for each e_sort items by node. This will loop through the enumerator's values. Add an exactly string node to the graph. Take the selected option pin from the event and connect it to the bottom input of the equal node. Then, take the enum value pin from the for each node and connect it to the top input of the equal node. This setup compares the selected drop-down option with the enumerator values, allowing the correct sorting logic to be executed based on the selected option. Connect the result of the equal node to the branch condition. Connect the loop body execution pin from for each to the branch. Start by dragging the slots container variable into the graph. Next, we need to create a new function. Open the WB_slot container widget from the content browser and go to its graph. Add a custom event and name it root sort items. From here, call the getOwningPlayer node. This will allow us to retrieve the owning player of the widget. Now, we need a new interface. Open BPI_player controller in the content browser. Add a new function named getControllerRef. This function will have one output named myPlayerController with the data type BP_myPlayerController object reference. Save and close this interface. Next, go to BP_myPlayerController. Expand the Interfaces section on the left and open the getControllerRef function. Connect the myPlayerController pin to a self-reference, ensuring this function provides the correct reference. Compile and save your changes. Return to the WB_slot container widget. From the return value of the getOwningPlayer node, call the newly created interface function getControllerRef. This allows the widget to retrieve the reference to the player controller. Now, go to BP_myPlayerController and add a new custom event named inventory_sort_by_server. This event will have two inputs. The first is inventory ref with the type BPC_inventory object reference. The second is sort by with the type E_sort items by enum. Drag the inventory ref pin into the graph and call the sort items by function. Connect the sort by input pin to the sort by pin of the sort items by function. Mark the event with a comment saying route to inventory, sort items. This helps to clearly identify its purpose. Rename the event by adding an root underscore to make it more distinct and easy to identify. Do not forget to set the replicates property of the event to run on server. This function serves as a helper and calls the sorting functionality in the inventory. Now, double-click the sort items by function in the inventory to ensure it is properly linked. Return to the WB_slots container widget. Drag the myPlayerController pin and call the root inventory sort by_server function. Connect the sort by pin from the root inventory sort by server function to the run sort items event. This will automatically create the sort by input for the event. Expand the components section on the left and drag the inventory ref into the graph. Connect it to the inventory ref pin of the root inventory sort by_server function. Why do we need this routing function as a client and cannot call sort items by directly? The issue arises because widgets do not have direct ownership in Unreal Engine that the server can validate for replication. Even if the widget is linked to a valid owning actor, calling sort items by directly from the widget fails with the error, actor does not have an owner. By routing the call through the player controller, which is recognized as the client's owner by the server, the root inventory sort by_server function ensures the call is properly validated and processed. The player controller acts as the server-recognized authority, enabling the request to succeed without ownership errors. Compile and save the changes. Go back to the WB sort by menu widget. Grab the slot container variable pin and call the root sort items function. Connect the true execution pin from the branch to this node. Take the sort by pin from root sort items and connect it to the enum value output from the for each node. Organize the nodes neatly and add reroute nodes to make the connections clean and easy to follow. Finally, select the custom event and add a comment saying, "Execute the sort action," to clarify its purpose. Move the comment slightly downward to create more space. Select the sort button, scroll down, and click the plus button next to unclicked. This will generate an event for the button's click action. Move the generated event up for better visibility. From the execution pin of this event, call the execute sort action event. Drag the sort by combo box into the graph and call the get selected option node. Take the return value from this node and connect it to the selected option pin of the execute sort action event. Next, select the sort by combo box, scroll down, and click the plus button next to on selection change. This will generate an event triggered whenever a selection is changed in the combo box. Move this new event slightly to the right of the other nodes to keep the graph organized. From the execution pin of this event, call the execute sort action event. Take the selected item pin from the onSelection changed event and connect it to the selected option pin of the execute sort action event. Select both events and add a comment titled sort execution trigger to clearly label their function. Compile and save your changes. With this, the WB_sort by menu widget is complete and ready for use. This concludes the episode. We now have a fully functional sort by menu widget. Next time, we will implement this widget into other UI elements, test its functionality, and make any necessary adjustments to ensure it works seamlessly. If you enjoyed the video or found it helpful, please consider leaving a like or subscribing to stay updated with future episodes. See you next time.